Okay. So we're using, if we assume something is normally distributed, we can make all kinds of predictions and assumptions. So if your data is distributed normally, you can convert it into a z-score, which will then give you statistics of every value. Okay, so x is some random x. In this case, x would be, in this example, x would be like the height. Okay, so suppose that the random variable x is normally distributed with mean mu and standard deviation sigma. Then the random variable is z is equal to x minus mu divided by sigma. So you can standardize anything that is normally distributed into z-scores. Okay, so it doesn't matter. So you can actually compare apples and oranges if you convert both sets into z's. Okay, that's the beauty of normal distributions. Okay, you can make those comparisons. Now, if it is normally distributed, that means that the mean is equal to 0. So once it's standardized, center is 0, and the standard deviation will be thought of as 1. So 1 sigma, 2 sigma, 3 sigma, when everything's standardized, is your standard deviation. The random variable is z is said to have the standard normal distribution. Okay, so let's go to example 1. So if a pediatrician obtains the heights of a 3-year-old female patient, so she gets a bunch of 3-year-olds that are female and creates a set of measurements, okay? If the heights are approximately normally distributed, so that's the key. So if this is true, then I can use this approach. And they give us the mean. So the average length or height is 38.72 with a standard deviation of 3.17. So given that, I can change any x they ask about. So find the probability that the 3-year-old females have a height less than 35 inches. So basically, if a random patient comes in, what's the chances that that person will be below 35? Given these facts here. But the way I want you to think about it is you have some x value, in this case, inches. You want to know what is the probability that it's less than 35. But you need to change that into a z. Okay, so z is equal to x minus your mean over sigma. So mu is equal to 38.72. Sigma is equal to 3.17. Okay, so plug it all in. X in question is 35. So this will be 35 minus 38.72 over 3.17. So that should be about negative 1.17, right? Down there. So convert this to z less than negative 1.17. Good, sorry, lost my train of thought. So you can use your calculator, you can use Excel, you can use all kinds of stuff to find that probability once you have this. So basically this is telling you what is the area to the left of this number. Okay. That translates to probability or the proportion. Let's see where Excel's at. Okay. Let me give you the Excel command here before I forget. Probability that Z is less than negative 1.17 in Excel is going to be normal distribution, I guess all caps. Now let's try it out. Normal distribution. Plug in your z-score, be negative 1.17. That should be our answer. Let me double check. Yeah, that's it. So the proportion or probability will be 0.1210. Is that straightforward? Okay. Let me double check one more thing. This is real quick. We won't have to do the whole example, but if your probability is between two values, let's say 35 to 40, I think we got to use a different function. Let me find the function. is. Oh, here we go. Okay, so the lower x is, let's call it XL, the lower one. It's 35. Stage should be the higher one, 40. So I don't forget. Answer. Hmm. Hmm. That was an easier way. All right, give me 1 second. Gonna find the function. I got two. Yeah, must be done that way. Okay, I was trying to find a shortcut and then it doesn't exist. So we'll have to do it the long way. Oh well. So the first thing you gotta do is change this to z-scores. So change the, we'll call this x1 and x2. Hit record again. So change, well, find z1, so that'll be equal to x1 minus your mu, which then this question was given as 30.72 and 3.17. So x1 minus mu over sigma. Z2 will be x2 minus mu over sigma. So this becomes 35 minus 38.72 over 3.17. This will become 40 minus 38.72 over 3.17. So this is negative 1.17 and this is 0.40. Okay, so what you do is change this guy into z's. Oh, I wrote that. Okay. But there is no function that does an intersection. They have to do two separate parts. Okay. So change this into, so this is equivalent as probability of z less than 0.4 minus the first part, z less than negative 1.17. Let me double check. Your calculator can do the in between two parts, but this one can't for some reason. Okay, so on Excel, this translates to normal. What's up? Well, what I'm doing is the function. You use Excel and give you all the area to the left. And it's being also all the area to the left, so you gotta subtract those chunks to get the end. So I'm gonna have to use the function for this one, that. So you can change this one. Their areas. Okay, so whenever you have an in-between value like this, a range of values from here to here, subtract the top one minus the bottom one, which equates to in Excel Where is the value? Okay, here it is. 0.4 minus negative 1.17. So you do this in Excel and you'll get the in between. Okay. That'll be about, let me see. So it'll be equal normal distribution of 0.4 minus normal distribution negative 1.17.
Different functions.
What's that?
Those are two different functions. It's like normal distribution. It's standardized.
Yeah. Entered. What did I use up here? That was normal distribution. Normal? Oh, normal is this. Okay. Originally I had the S. Yeah, so this one wants a Z. So I should have on the notes an S in the middle.
So the standardized would be this. That deviation would be 1.
Mhm.
Since it's standard deviation of 1.
Well, we standardized by changing it to Z's. So once it's standardized, then you can use this. If it is not standardized, you can use the other one. But you have to put all that info in, like the X, sigma, mean. There we go. So your answer is 0.5344. So just add an S right here. Okay, so now this is the R answer for sure, but I'm curious if we can use the other function to just get it all at once by using R sigma. So let me plug in sigma here in main. Do this somewhere else. Yeah, you could use the other formula, but it's more annoying, but I guess it's up to you. I'm gonna show you. If you do normal distribution, it's assuming you're gonna use the X values, like the heights, whatever, not the Z scores. So you would have to plug in 43.17, the 38.72. You do that twice, you do the top one for 40, all that's up in minus, that same garbage, well, 35. But if you standardize it on paper, you can just plug in the Z scores. I think that makes sense. But I think stack crunch might have a simpler function. The ID4 and ID3 have an easy one too. Doesn't matter to me. Let me show you real quick. You could do. So we know the answer is 0.534, right? You could go to second distributions and do I think it's a CDF. Put the lower bound of, let's see here, negative 1.17. Make sure you use the negative symbol, not the minus symbol. If you choose to do this. See how it's going to give us a 5.344. So you can do it with this, StatCrunch or Excel. It's not too bad either way. Okay, so just go second, hit the bars button to go to your distributions. If you have an 83 or 84, pick normal CDF. PDF is for a specific value. CDF is like everything between or after. Now, if it's a greater than, this, once you convert it, you did that earlier, that was a what? 40 was 0.4. If you're going to use Excel, you need to know that this is equal to 1 minus the probability of Z minus or Z less than 0.4. So if you use Excel, you just do 1 minus and then put the Z value in there. It's a normal S distribution. If you're using your TI-84, you'd have to go plug in a really large. Well, actually, you would put 0.4 as your lower number because you're starting there and going to the right. So the upper would just be something humongous because you go to the right forever. So it'd be something like this, probably being above 0.4, which is above 40. In Excel, this would be found like this. Okay. So I recommend standardizing first with the formula and then just plug in the value in. Okay. So the calculations aren't too bad. I just want to make sure you understand what the Z values are and how you can standardize any normalized data, normally distributed data. Okay. I'll let you guys work on your homework. I have adjusted the date somewhere off. Keep that in mind.